My name is Tim Hewer. I am one of the program managers on the Windows Developer Experience team, responsible for delivering the application developer story for Windows 8. I particularly have been focused the past couple years on XAML within Windows 8, and so I was asked to come and talk with you a little bit about what does Windows 8 app development mean from a .NET developer's perspective, from someone coming from existing UI technologies that we've been delivering in the Visual Studio experience, in the desktop, on the phone, et cetera, and kind of what has changed from a .NET perspective, and somewhat what has changed from a XAML perspective. Do we have any .NET people in the room? Awesome. Woohoo! So I thought I took a look on some UI platforms that I've worked on before. Maybe some of these are familiar to some of you as well. The one common thread about the ones that I found that I liked had a common thread weaved throughout it, and that was .NET. It gave me this consistent benchmark for me to be able to take my skills anywhere where I went, whether it was in WPF, in WinForms, on the server, in console applications, on the phone, in embedded. Wherever I went, this commonality of having the .NET framework and my language choice of C# and VB or other .NET languages, being able to take those skills with me. And so for me as a developer, that was very important to be able to leverage what I knew, be productive in the tools and language that I'm familiar with, and being able to carry that forward from the ASP.NET days of when it was originally came out and the introduction of .NET to today when, again, working on devices like the phone and with Windows 8 apps as well. So my twist here will be a little bit on XAML because that is the team that I work on. But I wanted to make sure that we took a focus on understanding the .NET perspective, the .NET developer's perspective as well. So I'm weaving in a little bit, maybe perhaps a little bit somewhat of what John talked about of creating Windows runtime components, how those are shareable, and maybe a little bit about how it's sharing these within native code as well. But then we'll get into some of the XAML specifics as well. So Windows 8 is here. Anyone installed or actually running the release preview? Lots of folks, great. So hopefully you've seen the announcement that we've completed a significant milestone in our delivery, and you'll be able to get your hands on that as developers fairly quickly, and we encourage you to move to that build and start building apps. So in Windows 8, we wanted to also bring forward existing UI technologies in addition to providing new UI platforms for Windows app development. So the HTML and the JavaScript story is kind of a new story for creating these apps that run on your machine rather than through a browser or through an internet connected device or something like that. We also wanted to make sure we brought that familiarity forward with existing developers. So if you're a C++ developer, you can leverage the same skills and write C++ applications targeting the Windows runtime APIs. Additionally, if you're a .NET developer, we carried forward the XAML UI platform as far as into the Windows runtime experience. Now, one note about the XAML stack is that it is a Windows runtime API. It is not created in .NET. So this is a little bit of a contrast from what existing XAML UI frameworks have, taking Silverlight as an example, where there's a little bit of a mix of native implementation, but a significant amount of managed code implementation as well. So one of the challenges we had in building this platform is actually making it a true native experience from a framework perspective. WinRT, everything is in Windows, is basically able to consume from any language that is able to get to those language projections. So even the simplest of angle bracket button in XAML, that is you using a WinRT API. Even though you're not writing any lines of code, by the nature of you choosing a XAML application, you're using the WinRT APIs that are available to you, in addition to the ones that you actually may call from your own code. The great thing about this is that you are, as .NET developers and C# and VB developers, how many people are using VB in production code in the audience here? A couple people, okay, so not a significant amount. But the great thing is if you have those skills, they carry forward. So you already have the skills familiar with to start building these applications. The C# and the VB experiences are identical. Obviously the language syntax is the difference there, but there's no lesser capability or greater capability in one or the other languages. .NET is a first-class citizen in Windows 8 app development, and you can use the language of your choice. Now, going out of the gate, we only support C# and VB. If you have your favorite COBOL.NET language and you really, really want to build Windows 8 applications in that, come and see me afterwards and maybe I can knock some sense into you. So the other thing that we wanted to do was to make sure that even though these are native APIs, that you are calling native Windows components, we wanted to make sure it was done in a familiar and comfortable way for C# and VB developers. So how you create new instances of these things and the different semantics in the languages. You should see no difference in writing a Windows 8 app targeting the Windows runtime APIs than you would as if you were writing the same code in Windows Form as an example. The code that you write is going to look and feel very familiar. So there was some concern of whether or not C# and VB were first-class citizens. Again, they very much are. You have access to all of the Windows.star namespaces, which is the Windows runtime APIs. How many folks have ever written this line of code? So this is an example of something that one of the goals of the Windows runtime is to reduce and remove probably some of the most common things of using p-invoke tactics in .NET. Now let me be clear, this isn't evil code. It's just if you're a .NET developer, it's inconvenient code to get at things that you may think are fairly simple. Let's look at a quick example here. If we look at this example, this is an example of doing a video capture from a .NET application if you were to do it today in Windows 7, not using any third-party libraries that may have wrapped APIs for you. Right, so I've got to DLL import some COM. I've got to make sure that I've got the right marshalling strings correctly, and I'm doing all these static X turns, et cetera, and then I'm able to call that. And this is, again, this is a lot of goop that is not entirely intuitive. It feels like, man, why can't I just directly call into the API surface for the capture create window? So by contrast, in Windows Runtime, the same type of code is this, right? It looks exactly like .NET. It is .NET. You're writing C# here. And I'm just saying, hey, I'm importing the namespace for the Windows Media Capture, and I'm just going to use it. I'm going to use it as familiar. I don't have to do any DLL COM imports or mark code as, here's unsafe code that I'm calling into. It is exactly C# as you would expect it. The Windows.star namespace is going to feel like the system.star namespace to you. You won't have to do anything extra or special or change anything in order to do that. And again, just to make it clear, if you need to p-invoke, there are some instances where you probably would, where maybe the Windows runtime out of the box is not providing anything for you. The example was brought up about SQLite. That's a good example. It's not a part of the inbox. Windows is not delivering that. And SQLite is a native component. It provides native APIs. In order to call into that from C#, you're probably going to need some type of callable wrapper. And you'll probably have to have some DLL import statements, unless somebody were to build a WinRT component that actually just calls those native APIs directly, which is possible. So one of the other things that we did when we looked at this is from the developer experience, we looked at, OK, what is the API set of a Windows 8 app that somebody's going to want to build? What are they going to want to use? And you saw Chris and John talk about all the different features so far that are available in Windows 8 and all the new contracts and things. And we want apps to exhibit these personalities. We want them to have a lot of this personality to provide a very consistent user experience for our customers and for your customers. And so we thought, well, we don't want to create the experience of I want to create a new application. And man, what is the DLL I need to reference? What's the where is it at? What reference do I need to include? Is it in the Windows namespace? Is it in the .NET namespace? Et cetera, et cetera. So we made a kind of bit of a strategic decision looking at the API surface and saying, you know what? It's small enough and compact enough that we should just make sure that every app has all of those APIs available without the developer having to think about do they have the right reference? So you'll notice when you're creating a .NET application for Windows 8 in Visual Studio that the references node, there's really two entries there, Windows Runtime and the .NET Core Framework. There's no additional things that you need to add as a developer to get access to everything in the Windows Runtime and the base class libraries that the CLR will provide. Anything that you would want to add additionally would be any third-party components or other SDKs that you would want to add. But out of the box, the file new project experience is everything's included for you, and the references are compacted into kind of groups, if you will. So you won't see a system.explosion in your references. You'll just see, hey, you've referenced the .NET Framework Core library and the Windows Runtime library. And I'll point those out. Now, some of the other things that we've done is we've removed redundancy in the library. Where base class library may have had things that have been available in Windows but were only exposed in native, now we've surfaced those to Windows Runtime, and there really didn't appear to make sense to have certain things exist in the base class library that did the exact same things that exist in the Windows Runtime to cause some confusion. So we did our best effort to make sure that we removed as many redundancies that made the most sense within those. So some areas, some examples and some that I'll show as an example like globalization. So a lot of the globalization APIs that are, you're creating a Windows app and you want to localize your app, well, you should use the Windows globalization APIs. And so those are actually Windows Runtime APIs. There really was no need for that same set of rich APIs in the .NET Core Framework because they're already being provided from the WinRT layer. So you'll see that bleed through in a couple spaces. But again, the consistency of being familiar and just kind of writing code instead of system.something, it's windows.something. It should be familiar for you. The other question that comes up, and I heard the question while I was sitting in the back, is what about portability between existing .NET code? I have a lot of business logic that I want to kind of maintain. How can I best leverage that? Well, one project that's been around for a little bit in .NET is this concept of portable class libraries. I don't know if anyone's had the opportunity to take a look at these. The project's been out for, I think, about a year and a half, maybe 2 years, in kind of like community preview mode. But Visual Studio 2012, it ships as a first-class citizen in Pro Plus SKUs. It's not an Express, so you do need a Pro or higher version of Visual Studio to get this. But the concept of a portable class library is, I have this logic, I have this .NET logic that I want to share between all my endpoints that I want to create. I want to create a phone app. I want to create an Xbox app. I want to create a Silverlight app, and I want to create a Windows 8 app. But I don't want to write 4 libraries. Or I don't want to have 4 projects. How many people have these, right? You have a solution. Well, actually, how many people are framework developers? Like you have, maybe even for your framework for your company or anything like that, right? Let's say you have a solution and you have 4 projects, right? Here's the Silverlight project. Here's the desktop project. Here's the phone project. And each one of those is really just a CS proj with a boatload of linked files, right? And then you've got if-defs all over the place. If conditional compile this, use this namespace, or do this method. The goal of portable class libraries is to remove that and to give you a binary compatible way of sharing some .NET code across those platforms that I mentioned. And so if you use a lot of the common development patterns, and I'll show a quick example using the view model approach, where you could have a common view model in a portable class library, and instead of using linked source files, I can actually have a binary dependency on my Silverlight application and my Windows 8 application using the same binary without having to do any conditional compilation, if-def, or now managing 2 sets of source files. It's not a bulletproof solution, so I'm not here to say that it's going to work for everyone. But it is something that should be considered, that you should look at if you need to find a way to use portable code across your different endpoints for the same application. Utility things come to mind very much in this realm for me. I can't tell you how many utility codes that I've written that I either copy and pasted the same thing or used linked files for this level of thing. So if you're a framework developer, if you have your own view model framework or your utility library on a Codeplex, or even, like I said, even within your own company, you have like a consistent way of doing string parsing or whatever, looking at portable class libraries is something that you should consider. The other thing is that, I mentioned we tried to remove redundancy from the Windows runtime and the .NET framework. And there are some areas where in .NET you need to get at something, but it's not, it's not the same type as what is going to be exposed from your receiving call of Windows runtime. So what the .NET Framework team did was create a set of extension methods to kind of bridge this gap. So an example of this is, let's look at a stream. So as I look at a stream, and I'm using the file picker APIs, which is Windows runtime APIs, what I'm going to get back is this input stream, or sometimes it's an random access stream, right? This is from the Windows namespace. You can see Windows Storage Streams namespace. And so the object type that I'm getting back is this input stream. Well, .NET's stream reader and stream manipulation doesn't know what an input stream is, right? It knows what a stream is, because that's what's been around for a while. So what the .NET team has done is there's the type we're trying to get at, and we're trying to use it within our system IO stream area. So what the .NET team has done is said, hey, we're going to create a set of extension methods on these things to bridge some of the more commonly used things. Stream is one of them, right? So on random access stream, input stream, output stream in Windows runtime, you'll see these extension methods. So I'm in Visual Studio, I have a great developer experience, I have my stream, I say dot, and now I have these extension methods that will bridge me to what I need to get to in .NET. So I can say, hey, I need to be able to read this stream, but stream reader expects a stream, not an input stream, so I can just say, give it to me as a stream for read. That's going to give me my stream object back, and that's what I can feed to the .NET APIs. So you'll see these extension methods all over the place within the .NET framework. I think probably this is a great example, because I think stream is probably one of the most used extension method for bridging the gap here. Because when you're working with the Windows storage namespace and a lot of the pickers and contracts, there's a lot of streams being passed back and forth. So this becomes very helpful. Now, I will say that you can get frustrated very quickly as if you immediately opened your Visual Studio right now and tried to write this code sample here. What this does a very poorly job is if you got to this line of code, you'd probably hit dot and you wouldn't see that extension method. So extension methods live in namespaces, right? So if you don't have the correct import or using statement, you're not going to see them. So just keep that in mind, that if the extension method isn't there, kind of intuitively think like, well, where would it be? In this case, I'm working with streams. I need this type of stream. So if in this code snippet, I need to make sure that I'm importing the system IO namespace for that extension method to show up. A lot of this, how does .NET work? Bridging the gap. How are they marshalling back and forth? Emo Landworth on the .NET team just recently recorded a podcast kind of asking that question. It was recorded with Scott Hanselman. This is just a short link to it. I highly recommend, if you're a .NET developer and you haven't heard it, or you haven't seen any of the build talks about the .NET relationship within Windows runtime. He does a really good job just kind of being very pragmatic about answering the questions of what's going on here? What do I need to know? How is the relationship between the CLR and these things? Does a good job, probably better job defining this projection term that we throw around. So a good listen. It's a quick listen on the drive home today maybe. So just keep that in mind. There's a short link there for aka.ms/winrt-netfx. So I also mentioned along with that familiarity and this concept of portable class libraries, a lot of people use development patterns in .NET, MVC, MVVM, or some of the simpler code behind patterns. All of these are existing patterns that there's nothing wrong with one way there's no wrong or right way. This software is an art, so it's just going to be whatever best suits your need. But we want to make sure that you can still develop using these same patterns. So from a XAML developer's perspective, you get kind of the out-of-the-box code behind experience, where I have a XAML object that represents a class. That class has a code file that I can wire up events and hook them to and do whatever. That's still totally available for you, completely accepted. It works great for probably smaller applications. As you get into larger applications and maybe testability or test-driven development is important to you, using more stringent pattern development like model view, view model, or commonly referred to as MVVM, is something that you may want to look at. And again, along with that familiarity line, we wanted to make sure that you would be able to do that. And so we fully support the view model approach for development as well as other patterns. So let's take a look at an example of this. So what I have here is Visual Studio Ultimate. And I'm going to create a new portable class library project. So again, the portable class library project is available to Pro Plus. So if you have only the Express edition, you won't see this. But I have this here, so I'm going to create a portable class library project. And I'm going to call it the shared view model. Because my goal is I want to create a Silverlight application and a Windows 8 application. And you'll see very quickly is that I get this dialog that tells me like, hey, what kind of things do you want to target with this portable class library? It's cafeteria style, right? So I can say, yep, I want to target these things look good. Nope, I want to target Silverlight 5. You'll notice once I choose Silverlight 5, it says everything you've chosen actually still applies to Silverlight 4 too. So we're going to just let you know that we're going to downgrade basically your choice because it's still compatible with the lowest common denominator there. Now an example is, like, let's say I want to do, let's see if I can find an example that might force me to do something here. They've done a pretty good job making sure a lot of this is compatible. But you would get a warning if you chose an option, if you tried to say, hey, I want the latest and greatest of everything, but I'm still on .NET 2, so to speak. And I think we removed the 3.5 from here as probably a mitigation factor. But I can choose all these areas. And what this does is just essentially creates the set of reference libraries that I will be able to choose from. So in my project, in my IntelliSense, in the compiler, everything is just going to kind of enforce this set of reference assemblies that meet the expectations of that profile that I just chose. Question? Yes. Yes. The question is .NET for Windows Store is for Windows 8 apps. Correct. So I have this shared view model class here. And we'll just call this the person view model. And we're going to add some pretty standard code in here. And I'm just going to use some code snippets to help move us along from time perspective. Common pattern in a view model is to implement iNotify property change. Oops. And changing your keyboard to non-English doesn't help. Oops. Am I getting the name wrong here? Come on, peer review, guys. OK, so I've got this view model, which basically this concept of iNotify property change allows me to get change notifications. I'm not going to go deep into what view model is, but it helps assist in what XAML's binding engine and being able to pump changes from your data up through the UI. So I've got this thing called person name, and whenever person name changes, I want to raise a change event, which will again trigger to the binding engine that things will change. Now I also want to attach some events to this. So I'm basically separating my UI from my logic. In the code behind pattern, right, if I had a button click event, I would just have a code behind event that's that button's click event handler. But in the view model approaches, we kind of remove that and we implement commands in our view model that we bind to the view. And so one of the things that a lot of people do is create these I commands. And this is a very common approach using the delegate command approach. So this is just kind of a stub for a command, and a command is basically just going to tie to an action of some logic that I have here. So now that I have this class for a command, I can go back in my view model here, and we'll just add, let's get some includes here. In the constructor, I basically created this command here, and I said I'm going to have something called a save person command. And that save person command is going to be one of those new delegate commands. And the action that it is obviously not an action that you would want to do in a real application. But for simple purposes, I'm just going to do a write line out to the debug window here. So I've got my view model, compile my view model, everything is well here. And I'm going to create a Windows 8 app. And I'm going to add a reference. Let me just set it as a startup so I don't forget. And I'm going to add a reference to this shared view model. Now I'm adding a binary reference. Notice that I didn't add the files as a linked source file or doing any conditional compilation. I am doing a project-to-project reference, but for all intents and purposes, that's a binary reference. I could have browsed to a DLL at this point. Same thing. So now in my XAML project here, what I'm going to do is just going to add what you normally would do for a view model approach is I'm going to add a resource that represents my view model. Now here's one of the differences between existing XAML platforms and the Windows 8 XAML platforms is in order to do this, I need to use an XML namespace. And I'm back in my German keyboard. And so I want to give it this namespace of portable. Now what would normally be here? If I was using Silverlight in a .NET world, you would see, hey, I want to point to this CLR namespace and give it this namespace and assembly path reference. Well, since we are a complete native component, and XAML, if you didn't know, XAML is now available for C++ developers as well as DirectX developers. So the concept of CLR namespace and the way it maps to assemblies, also in accordance with the WinRT rules of how APIs are written, no longer made sense. So we use this new using approach, which is very similar to what you would do in C#, is you say using and then the namespace is shared view model. And so now once I have that, all my IntelliSense errors go away. And so let's actually put some code in here. And so I just have a simple stack panel. And the command, so button base exposes a reference to that I command interface. I can bind a command to that. And I'm saying, hey, I want you to get your command from that view model. And the command you're going to execute is that thing called save person command. And now I'm doing some, the parameter that I'm sending into that command is the person name element here and the text value of that. So if I run this, we'll get a very lame looking application. I can put my name. I click save. If I were to go back into the debug output string here, we would see that here's, oops. There is the output of my name right there in the debug string. Okay? Not terribly exciting. Now let's go ahead and into our solution add a Silverlight project. Now it shows the defaults. And I'm going to add, again, I'm going to add a reference to that shared view model. There's a binary reference. And go into the main page here. Let's do a quick compile. And again, I'm going to add XML namespace portable. In this case, what it's going to emit is the CLR namespace reference instead of that using reference, because that's how Silverlight knows how to look things up. But I can actually even just go in here and just copy the same code. And instead of page resources, since the default template in Silverlight is user control instead of page, which it has a page class, but we're just going to add that into the user control references. So I'm not writing any code in my Silverlight application. Let's set that as startup. And the exact same XAML that's represented here. And so I have the application. You know, the UI is going to look this, slightly different because the templates are different for those styles. I go back in my application here, and you can see in the debug window there's Bill that was output. So now I've been able to share code from a binary perspective by using this concept of portable class libraries. My .NET skills are leveraged across same logic and different endpoints that allow me to do that. So portable class libraries is a mechanism that allows you to do that. Again, very simplistic example. Your instance may be hugely complex and it may not work, but something definitely to investigate if you haven't looked at those before. Now, the other thing that John briefly touched on, and I saw there was another question during his Q&A, so I wanted to make sure I touch on it again, is that your .NET skills also transfer to the new developers that have access to Windows 8 applications, JavaScript developers, native code developers. I can use my .NET skills to write new Windows runtime components and extend those to C++ and .NET developers. There's some rules that I have to follow, so I can't just be carte blanche about it, because now I'm creating a Windows Runtime API, and so I need to conform to those rules. The key is that only the public API surface area of your WinRT component need to follow these rules. So I can still have internal and private methods that do a lot of complex and traditional .NET things, but once I expose a public interface, then it has to conform to these rules. So a public type or a public function that has to conform to these rules. And here's an example of some of them. Some of the most common ones that are going to get people tripped up is that public classes need to be sealed. All the types that are public need to be compatible WinRT types or derived from WinRT types. So I can have a foo object be a return value as long as foo object maps to some WinRT type. I've derived it from iIterable or iList or something like that. That's acceptable. Now, Visual Studio has great support for doing this. Let's again just take a quick glance at two concepts here. Now I am going to go into Express now, and I'm going to create a new Windows Runtime component. So you see we have this project template here for you. And when I choose this template, it sure looks a lot like the class library template, right? I mean, I just got this project. This is going to be a DLL, and I got a class file. What's the difference here? Now, I've seen a lot of people, a lot of SDKs, people create things that they're calling them, oh, WinRT toolkit, here's my C# WinRT toolkit, et cetera, et cetera. If your output type is not a Windows Runtime component, you are not creating a WinRT API. Keep that in mind. If you create a class library, even though it's a class library targeted at the core framework library, if you are not producing a Windows Runtime component, which is simple setting up here, you are not creating a Windows Runtime API. That means it will not be accessible for JavaScript developers, native code developers. So this is the key bit here. And in fact, the class library project template and the WinRT component project template, the only difference is this setting right here. So I could go back and switch this to a class library or Windows Runtime component. So keep that in mind. So now I can go back in here and say I've got this public sealed class, and we will just create a simple function. Say hello. We'll take in a value. I'm just going to do my normal things that I would do in .NET. Get to use all the BCL coolness. And there, I've just created a Windows Runtime component. How do I know that? Two simple things. Obviously, that value that I've checked, but the output is a WinMD. Now, in native code, when you create Windows Runtime components, you produce a WinMD. That's that metadata that John was talking about. And so in native components, you'll have a WinMD and a DLL, the implementation, the metadata that describes it, and the DLL representing the implementation. In .NET, we've compacted those into one. So this WinMD file is not only the metadata, but also the implementation. So I can email you this WinMD file. You can add a reference to it and get this function. You'll see that there's no other DLL file here. So now let's go in and let's add a JavaScript project. Set it as our startup. And I'm not a JavaScript guy, so I cheat even more. So I'm going to add this script here. Actually, first thing we need to do is add a reference. So we're in a JavaScript project. I'm adding a reference to the Windows Runtime component we just created, which is Windows Runtime Component 3. I have this code here. Now notice that in my JavaScript code, I just say, hey, new Windows Runtime Component 3.class1. And like what John was saying is that notice how it creates the API signature in a way that that language would like to represent it. In this case, JavaScript likes to represent it in camel casing, and so that I had an uppercase S in my API, and the projection layer took care of that for me. So I didn't have to do anything there. So I have this. Let's go. And if we run our application, we've got a JavaScript application that when we execute is actually calling into our C# code and returning those values and marshaling that data across for us. Again, very simple example, but it works nonetheless. Let's take perhaps a more XAML approach to this. So I'm going to create, what I want to create is, I want to create a Windows runtime component as well. But one of the key things that we just showed in the JavaScript and the C# side of things is that I can easily create a function that's used. What if I want to share UI? So that's one of the boundaries that can't be crossed between JavaScript and C# XAML. So I cannot create a custom control, let's say a charting control, that has XAML UI, and a JavaScript developer cannot consume that. Okay, that is one of the things that you will not be able to do. But what I can do is maybe I'm an ISV and I want to create a control suite, but I do want to expose it to this new class of native developers for XAML. So I can do that as well. So I've got this Windows runtime component, and I'm going to create a custom control. And so we'll say custom control. I've got a template that does that for me. If you're not familiar with custom controls in XAML, you basically create a default XAML template with them and apply this default style key here. So let's add to that template here. Let's just give us some visual here. So I'm going to say the font size is 53. The text value is going to be a template binding to this property called some text property. But some text property doesn't exist, right? So what would we do? We would normally go in here and we would create, in XAML we call it a dependency property. It's something that can participate in binding, that's settable from UI, et cetera. Now, we have good code snippet support for dependency properties. I can go in here and just say some text here and custom control 1. And I've got this good support. I've got my standard definition for a dependency property. And that all looks good and well. And now if I was creating a standard .NET application, this would work. Now let's compile this. Oh, I got some errors. So the default code snippet for dependency property does not, basically breaks one of the WinRT rules as far as what public structs can be exposed as, or fields can be exposed only by structures. And by default, that snippet doesn't allow that. So we can make some minor tweaks there just to change this and still get the functions that we want. And in fact, I've actually just made a different code snippet that does that for me. So we call it some text property, custom control, and I don't have any callback. So now I've created this, you can see basically the subtle changes here is I've created basically a public static dependency property that's not read-only, and that the getter basically gets the private registration of that dependency property. Again, very minor change, but this allows me to get past the rules. So now I can compile this, and now I have a WinRT component. So if we look at the output, I have a WinMD file that represents, this is now a WinRT API that allows me to share some UI. So now, remember, this is C# that I wrote in C#. I'm going to go into C++ and add a XAML application because I want to share this UI here. And I'm going to add, set that as my startup. I'm going to add a reference. For some reason in C++, adding references is like 10 clicks. So I'm going to add a reference to that Windows runtime component and just do a quick build, make sure all is well. And now I'm going to go into my main page here. Again, I'm going to add the, I think I'm going to add, we'll just add a namespace called custom. And there's my Windows runtime component 4 there, so I'm just going to use that. Now I'm going to go in here and just say custom control. We'll give it a red background. And what was our property? Some text here. You can see I get IntelliSense, right? This is native code that I'm writing. Some text property. Awesome. And if we run our C++ application now, it's compiling. It's using the C# WinRT API that we created. And now I'm able to share UI. So I've created, I as a .NET developer have just enabled a native code developer to use a control. And so we think this is a good story. And again, if I were to create a C# application, I could use this as well. JavaScript would not be able to use this WinRT API. It would probably be some runtime exception, just because the UI rendering platforms are different enough that there's no interop capable there. But if I was a DirectX application and I wanted this particular incredibly lame user controller I just created in my awesome DirectX game, I could do that because I've just enabled that. So being able to extend the APIs is something that we looked at and are able to do. Let's take a look at some of the new XAML aspects. And I'm going to skim through some of these looking at time here. So I'm going to just create a quick application here. And let's go ahead and add a stack panel and a button. And what I'm doing here is I'm adding a scroll viewer and an image here. And in this click event handler, we're going to write some code to load some file here. So we're using we're using WinRT API libraries. Now one of the things that John touched on too is async APIs. And so the developer tools do a good job of letting you know, like, hey, here's this red squiggly. If you look at the bottom, it says the await operator can only be used within an async method. So you got to change this or change its return type. So I can get rid of that by quickly going to this. Another thing is that if you look at the IntelliSense on methods, not only did we name them, foo method async, but in the IntelliSense we tell you, hey, this method is awaitable. So it gives you another hint that you can do simple things like this. And so now we've got this code. We're going to load up this image from our picker, and we're going to set it. So let me just run this. So we just created a quick C# application. I'm going to load a file. And what's cool is because I use that picker API, I've had to write no code, but I can integrate with SkyDrive because SkyDrive understands what a file picker is. So I can take a picture of my kid. And there we go. I've loaded from my app in a few lines of code, I've loaded a file from SkyDrive. Not having to worry about the SkyDrive SDK, just load it in there. Now, if I wanted to do like pinch zoom capabilities, maybe I wanted to build like a photo manipulation application, and I wanted to test that. Scroll Viewer is one of the new things that we did in Scroll Viewer for XAML is we've enabled gesture support built in as kind of a default for the foundation. So if I want to do pinch zooming, et cetera, or panning, you can put things in a Scroll Viewer and get that behavior for free. Now, I don't have a touch machine though, so why isn't this working for me? So if you don't have a touch machine, or the senior guy on your team got it because he convinced the boss, you can use the simulator to get this same behavior. So I can load up the simulator, do the same behavior here, and then I can simulate touch. So if you look in the simulator, I have all these different gestures. So I can simulate pinch zoom behavior. You can see it gives me these things here. So if I have a mouse wheel, I can hold this down and use the mouse wheel. And because I'm in a scroll viewer, I'm getting this manipulation behavior for free. So using things like Scroll Viewer will help in your application. Again, just kind of demonstrating something that enables you to quickly get behavior for free without having to do that. All of the XAML controls that we've done for you basically exhibit all of the behaviors that you would want in the Windows 8 story. So for sake of time, let me just kind of go through an application that shows some of these. So you notice how, and this is Cocktail Flow, this is available in the store. You notice how when the application came in, everything animated in, and Chris just got done talking about these animations. So this is a grid view in XAML, a new control for XAML. And the developer didn't have to do anything, right? They just populated the grid view. Those animations are there. That's part of the grid view behavior. So you didn't have to do anything. Now, you could, as a developer, go above and beyond and say, I just have this plain panel. That's not a grid view, so it doesn't have these built-in things. But when I move this panel around, I want a certain animation. Well, we expose that animation library to you as we call theme animations or transitions. So in my XAML, I can say, hey, I got this stack panel. Stack panel, whenever you move, I want you to apply a reorder transition. And so by default, that will trigger the system animation that will, is in a best performant way and animate that object independently of your UI. So using the animation library gives you independent animations above and beyond your UI thread. Now the other thing that grid view gets you, the capability, so I'm hitting the control key and mouse wheel down, is this concept of semantic zoom. So semantic zoom is a new control that we've introduced in XAML to make sure that we can get that same Windows 8 user experience easily for XAML developers and for .NET developers. So in a semantic zoom control, I basically say angle bracket semantic zoom. Here is my zoomed in view, and here is my zoom out view. And I'm going to give you some information of how the data would relate. Now in most cases, the data is going to relate. If you look at this, we went basically from an exploded group view to just the groups, not the details. Now some people want to use semantic zoom for kind of a master detail approach. If you do that, and you can, you're just going to be more responsible for, again, describing that relationship of that data between the zoomed out and the zoomed in. If you use standard grid view controls, you'll get this behavior relatively cheap. I'm not going to say it's completely free, because you do have to do a little bit of work for your data binding. But other than that, once your data binding is all hooked up the right way, the zoom out, zoom in behavior you get for free. So now I can go in and say, I want to click by type, and you can see that now I'm drilled right into that zoomed in view for there. So that concept of zoomed in, or sorry, the semantic zoom is there for you. You can see all these other animations that this app is using. Now I just right-clicked and I got an app bar. Again, a new control available to XAML for you, something that doesn't exist in other platforms. That all you do is you have to use the app bar and you get the correct behavior that Windows wants you to have, the operating system wants you to have. The animation is correct. We've provided a set of styles for all the buttons that you can use. So that you can just say, hey, I've got this button, and I know what a button is. I know how to work with a button. I can do the command binding to a button. But from a UI perspective, I can just apply a style that makes sure it gets all the behavior and the aesthetics of what the button is supposed to be. Right? So I have the mouse over behavior, the click behavior, et cetera. It's in the right position. It's accessible. So screen readers would be able to read it. So we've done a lot of work to make sure that, that this will be able to happen for you. Now, one of the other changes is, I'm going to breeze through a couple more here, is the concept of localization. How many people have actually written a localized app? Wow, shocking. So I was in the same boat, because I think, we, as developers, we think, English is fine. I think if you look at the opportunity for the Windows Store and your apps to expand to a global market, you should really consider localizing your app. And we hope that we've made it easier for you. And there's a lot of services. There's actually a multilingual toolkit that will allow you to do machine translation. Granted, machine translation is not always 100% correct. But while you're waiting for your buddy in Germany to do the correct translation, you can get machine translation from using Bing. So one of the things that we've done here is, let me just add some XAML here. So I've just got a stack panel, and I'm going to add some content. So we're going to create an app that's localized in German and English. And so this is a difference from .NET developers today. So in .NET, when you do resource management, and actually even if you're not doing localization, this will apply to you, so don't fall asleep just yet. The resource management is usually done through resx files, right? And you compile them, you get a strongly typed class file that represents that. Again, to maintain a consistent way of doing things across Windows runtime, there's no concept of resx or strongly typed files in .NET. The resource management capabilities are the same in C++, in C#, in VB, and in JavaScript. So they use the common WinRT API structure. And in .NET, we did lose a little bit of not having that strongly typed resource. However, you can get that back. It's not that hard. The strongly typed resource was actually just a wrapper around instancing a class and calling getString on the property. So you can still get that if you need to. We think that we have a simple way to do this here. And one of the ways is through this concept of XUID. So XUID is an attribute you can add on any UI element. And it's a unique identifier for that particular view. In the concept of localization, it is a unique identifier for a key. So even though I have XUID hello button, if I had a different view that had XUID hello button, for the purpose of resource management, that UID is truly unique to the application. So they would represent the same resource string, sorry. So let me go into English, and I'm going to add my string table. And we have this thing called resources res_w. This should look familiar. The reason why it's familiar is because the underlying schema is resx. The only difference here is we just don't generate code. That's the only difference. If you were to open this up in a text editor, you would actually see the exact same thing there. So it is resx. So we had that thing called hello button, and I want to localize that. So what we've done is kind of create this mail merge concept, is that I give you the UID of the element I want to localize, and then the property that I want to localize. So hello button is the key, and the property, I know it's a button, and so the property that I want to display is the content. So I'm saying hello button.content is the literal key for this string. So I've said hello there is the value there. So now I'm going to go into my German folder here, add the same named file, resources.res_w, say hello button, content, hello, begins. And so now I've provided a string resource for English and a string resource for German. And I've set this here. Now one thing I want to call out is in my design time experience, notice how I have a different value. One thing we couldn't get to in this release is to do some dynamic interpolation of what you have in your resource files. So if you need it to show on the design surface, you do need to provide a default value in your design experience. But I notice how I have it high here, but that value will only show in the designer. It won't show anywhere else. So we can run this application now. And I'm running English, so we should see a picture of myself and the button on the left-hand side. Now, how would you normally test localized apps today in Windows 7? I got to go download a language pack. I got to install the language pack, change my regional settings, et cetera, maybe reboot the machine. Who knows? In Windows 8, we have this concept of language list preferences. An application model honors the user's language list preference. So here, I actually have an English OS. So what I'm saying here is I have an English OS with 0 language packs installed. But I might be German, and I might say, hey, if there's German content, I actually prefer it. My OS is going to be English, but I prefer German where available. And so by doing that, notice I just changed my preference here. I'm going to rerun the application, and we should get German content. There we go, the Hof. And so the application runtime understood what to do and where to get things. Now I can say, wow, in German, this button, I actually can't even see anything there. So I'm going to stop this, go into my German resources, and say, hello button. The width actually needs to be 175. Save that, run this. And again, we do all that for you. So we haven't changed any of the XAML, but you as your localizer can say, well, actually, the translated string for Go in Finnish is, longer than just GO, and so you're going to have to make some UI changes there. So the way that the system knows to do that is that we automatically index these things for you. And you notice that in my page here, I'm just adding a reference to the image th.jpg. But because the application, when it loads, our app model knows, hey, the language list of the user is German first. Is there anything that's been indexed for German? That represents th.jpg? Why, yes, there is. OK, well, give me that value instead. And so there's kind of like this DNS lookup, so to speak, if you want to think about it that way, that allows me to say, I've been asked for this resource, whether it's a file-based resource or a string-based resource. Given all the context that you have, language list, operating system, et cetera, what is the correct match for that? In this case, it does it for us there. So that allows us to do this here. I can even go in further and say for the German, I want, so I can go on the image here, and we can go even deeper into profile image. We can go even deeper into elements for attached properties. I can say profile image dot, and then I have to do some tricky things because attached properties aren't on the element themselves, right? So there's XAML controls. Tooltip service. So I can kind of provide this metadata to describe this. And run the application. And notice I didn't provide an English value because I don't really need it. But now I've essentially been able to add an attached property through localization. And that allows me to do that. So we hope we've given a flexible model and kind of the shift away from a strongly typed resource. But again, it's not that difficult to get that same behavior if you want to use the standard data binding approach to localization here. Okay, so we went through, mentioned a couple other things about the XAML stuff. If you're an existing XAML developer, the same primitives are there, and for the most part, I would say 99% of the time, they act and have the same attributes and act the same as well. The big difference will be is that we made sure that we optimized for the Windows 8 experience. So they're already built in to handle touch behaviors for you. So if you have a combo box as an example, in your combo box, when somebody opens it with their finger, they'll be able to scroll and pan and do all of that for you. You don't have to add any of that logic. We've taken care of the hit targeting and testing for touch for you. So they're very optimized for the Windows 8 experiences. So there's new UI controls. I showed us a little bit of the semantic zoom, the app bar, et cetera. From a XAML developer perspective, they're just new angle bracket object types. So you'll program against them the same way you would. You should expect data binding to work the same way it would. They're just different and new experiences for Windows 8. The animation library, again, almost all the time, the controls that you use will have an aspect of the animation library, and you shouldn't have to do much. But it is exposed to you to add additional animations on things that you want to do within your own controls or within your own app. I mentioned the resource localization. We did a quick example there. Again, it's very simple to do. I would encourage you to, if you're writing Windows 8 apps, the great thing about the model that we've chosen is you can create your English app, put it up in the store, send that res.w file off to your German buddy. They give you the string translations or image translations. You go back in, you just add that folder in your project, and you repackage. And then upload to the store. And so you get that your app is localized without any code changes there. From a data perspective, running a little short on time. I want to make sure you guys get lunch. From a data perspective, all the data things that you know as a .NET developer, you should expect to be there and to work the same. So if I have a WCF service reference, I can add a service reference to that WCF endpoint. I will get strongly typed proxy code generation. In fact, I'll get even better, right? Because one of the things that we talked about was async APIs. So if I'm in a Windows 8 app and I add a reference to the Microsoft Translator APIs, if I was in a .NET 3 app and I did the same behavior, in the .NET 3 app, I would get completed event handlers and I have to chain events through. In .NET 4.5, when I do that behavior, the service reference module is smart enough to know, oh, I'm targeting a framework that is able to do async APIs, so I'm going to generate awaitable methods for you. So not only do you still get the strongly typed APIs, but I also get that async capability in the code. OData is the same story, so OData will generate code for you. A word on OData is that in the release preview, it's only included in Visual Studio Ultimate, and there's no good way to get it in the Express Edition. In the release, in the actual RTM of Visual Studio, it won't be available in any of the SKUs, but you'll be able to download an add-on that will give you OData capability. The reason why they chose to do that is to give them greater serviceability against the OData protocol, so they're not tied to any particular product's shipping cycle. But again, you'll just be able to go to a site, download it, and get OData capability there. We also enabled anonymous type binding, so you're able to, the most common scenario for .NET developers is probably parsing JSON formatted data and not having to have if you're just kind of doing read-only data binding. Let's say you want to get your Facebook feed or Twitter or whatever, these things that are giving JSON data and you don't want to create a class to serialize into. I can actually just query, using the Windows Runtime APIs, windows.data.json, I can actually parse that JSON tree and do an anonymous link query and say, for each or blah, 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 select, and just kind of select the elements that I want out of that tree and bind that to some item source without having to have a class representation. So very flexible in that need. For local storage outside of server storage, you have the windows.storage namespace is very synonymous with the isolated storage model in .NET. You should see them as exactly the same. It's file folder based storage that is contained for your own app domain. You also have the capability of using the ES or JET engine. It's basically like an ISAM-based database that you can access. I would say it's probably the most difficult for a .NET developer to get to that because there is no Windows Runtime API for that, and there is no managed interface for that. There actually is an open source project for a managed interface for that, so you can do it. But you're going to be doing a little bit more work. That's the engine that runs the IndexedDB for JavaScript apps as well. Or we have the third-party options that someone asked about SQLite earlier. You do have the capability. We work with SQLite to make sure that they have those capabilities for local persistent storage that's queryable for developers. So I'll skip that. So again, just to sum up, if you're a .NET developer, like all your skills completely transfer. You're just learning a new API set. On the XAML side of things, if you're a XAML developer, most of everything will be familiar to you. You'll have new controls and new experiences to expand on. Some things won't directly translate. I know there was a question about, hey, can I just take my Silverlight code and put it there? In some instances, you might be able to. The CLR namespace and using concept in the XML namespace will definitely trip you up. However, I would ask you to rethink about that question of how you're asking it. In Windows 8, you're creating different experiences than you would in Silverlight. On the phone, you're creating you're targeting a different user interface and different screen real estate than you are on Windows 8. So maybe thinking about it of how can I leverage that same logic, get into that view model approach so that I can share that middle component and my views are completely different and optimized for those experiences on the various endpoints there. But you could also create Windows Runtime components as we showed from a UI perspective, accessible to all XAML developers, or from a just utility perspective, available to all WinRT developers, including JavaScript. So you already have the skills to build great Windows 8 applications using the C# and VB skills that you know. And I hope that you find it familiar. And I hope if you have problems, you will let us know so we can improve upon them in the future as well. So thank you for your time. I won't take any more of your lunchtime. Since it's lunch, I'll be happy to stay here for a while and answer any questions. But thank you very much, and good luck on building your apps. And if you make $1 million, just $1 royalty is all I ask. So thanks again.
Thanks, Tim.